Hello, everyone. Thank you for attending. Again, my name is Todd Prives. I'm a product manager at Google, and I work on a number of different media rendering solutions. A significant amount of my time is spent on Zync, which is our rendering platform as a service. And during today's webinar, I'm going to show you Zync running inside of Cinema 4D, show you best practices for rendering at Google scale, which I'll explain a little bit more, and then take you through an actual render from Cinema 4D and show you how I'm able to cut down a render that takes about 21 hours on my local machine, which I'm working on now, and we'll do that in really a matter of minutes using cloud rendering with Google. So I'm just going to go ahead and start by giving you a very brief overview of what Zync is and how Google is now embracing the media space for rendering. So again, as I mentioned, I'm the product manager for rendering, but Google really has a suite of different solutions. So whether it's file ingestion, transcode, long-term archival options, or distribution, and of course rendering, Google has built a platform offering end-to-end solutions for all of these different types of your workflow. And so at its core, as I'll show you, what is Zync? Zync is essentially infinite scalability when it comes to cloud rendering, and it's backed by Google Cloud Platform. This is a Google product. We were acquired by Google about 3 years ago, and ever since then have been focused on integrating with different software packages and really scaling the power that we give to you, the end user. So in a nutshell, think of Google and think of Google Cloud Platform as the infrastructure that powers billions of people, right? If you think of Google as a company, we have 7 products with over 1 billion users. So the massive amount of infrastructure, of storage, of compute, of networking that's needed to support all those users all around the world, 24 hours a day, 365 days a year, that same infrastructure is part of Google Cloud Platform, and that's available to you as a render farm. So really think of unlimited scalability and power to render your Cinema 4D projects on demand as you need them. So I'm going to go ahead and show you the Zync interface in a few minutes, but really just want to talk in detail about some of the things that we find really special about Zync and that Google Cloud Platform helps us do. So the idea of having machines on demand is something that we offer, I think, at a capacity that's pretty much unmatched anywhere else. You're not competing for machines with other people. You're not talking about a farm that has a limited number of machines. You literally have, right now, up to 500 machines, and that's 32,000 cores. And those are on demand for you at all times. You're not having to compete with anyone else for those machines if you so choose. So it really is on demand, and all of the billing is done on a per minute basis after the first 10 minutes. So let's say you're rendering a job and it takes you 21 minutes per machine. That's all you're ever going to pay for. Nothing gets rounded up. It is literally on demand to the minute. And of course, with this, there's no subscription fees. There's no ongoing costs. You really only pay ever for what you consume. All of this is based around a set of plugins and a web interface that allows you to work exactly in your environment. So we have tools, plugin inside of C4D, which I'll show you in a moment, which really allows you to control the workflow and work normally inside of C4D just like you usually would. And all of this is backed with a web console render manager that allows you to see all of the machines that you're running for rendering in real time. And the interactivity is just like you're on a local render farm. Again, some of the key points here to cloud and to what Zync offers is the ability to avoid any of the upfront heavy costs that go into buying and maintaining a render farm. Imagine, if you will, needing, let's say, 500 machines for a job, or even 50 machines for a job, which can still be quite a large number of machines. Trying to provision those and set all those up, configure those, license all of those, manage all of that can be quite daunting. With Google and with Zync Render, it eliminates all of that. So you're only, as I said before, paying for what you consume. There are no capital costs, and the scale, again, is really something we're very proud of. As I was saying, you can run parallel jobs with up to 500 machines, and currently we offer up to 64 core machines. That's a total of 32,000 cores per customer, so pretty powerful. The workflow, as I'll show you in a little bit, is all designed around an intelligent asset synchronization. So you would work on your local workstation like you normally do. Nothing changes whatsoever in terms of takes, in terms of render layers, in terms of the renderer you're using. And what Zync does is sync all of those assets to Google Cloud Platform, allow you to do rendering on C4D, and download those frames right back out to your local directory that you've set at your facility. We also support Nuke, so in the case of if you decide to then render your C4D images inside of Nuke as a comp, Zync also supports that. And the nice thing about Zync is everything that you render on Zync stays on Zync. So if you're to render something on C4D, you get a copy back down to your local output directory, as well as a copy stays on Zync. So then if you move over to Nuke and actually set up your comp and set up a render, you don't need to re-upload any of your C4D renders. They're already stored on Google. Google knows it's there. So the I/O time is really minimized. And I'll show you this in a little bit more in depth as we get into the Zync plugin, but really it is all about maintaining a unified, easy to manage workflow inside of C4D. As I'll show you here, we have asset management set up as well, and right out of the box, it takes about 5 to 7 minutes to set Zync up, and you're off and rendering. There's no configuring of virtual machines, of managing licenses, of managing asset synchronizations. There's no FTPing you have to do. There's no VPN. Literally, Zync manages all of that for you. And we're really happy since we've launched support for Cinema 4D to have a number of high-profile customers in visual effects, in animation, in motion graphics. Now using Zync for render, you can see some of our clients here, including Swordfish here in San Francisco, where I'm based, as well as studios like Brand New School and Imaginary Forces. So I'll be happy to take questions at the end of this webinar, but if you have any questions beyond that, you can always email us info@zyncrender.com. and visit our website, which is zyncrender.com. And there you can sign up for an account, which comes with $300 in credit, which is close to 300 full hours of Cinema 4D rendering. And we'll cover that in a little bit more detail. But now let me go ahead and actually jump over to the Zync interface. So I'll go ahead and open up Cinema 4D here, and I have a project. So essentially, Zync is accessed through the pipeline menu inside of C4D. So now as I scrub through this scene here, you'll see we're going to render this in a few minutes. It's a nice, cool scene of some robots fighting here. I'll just scrub through it slowly so you can see some of this. But literally the fantastic work that Maxon has done with us allows us to provide access to Zync directly from the C4D application. So you have to have R19, but when you go to the pipeline menu, you can actually see here at the bottom, there's an option for Google Zync. Now, if you don't have Google Zync already installed, you won't have this render with Zync option. And this, of course, since I do, is how I'm going to render. But even before that, you can get to some information about Zync and start by downloading the plugins through the client app. So if you're new to Zync and you want to go ahead and download something, you go ahead and click on Download Installer. That'll bring you to our page to actually go ahead and download the necessary software. We have the account setup option, we have more information, and we have tutorial videos. So I'll go ahead and click on more information here. When you click on that, it's going to launch in your web browser our Zync render page for Cinema 4D. So here you can read a little bit more about the product. You can read about the supported applications, which actually is now going to be updated to say R19. But we do include the standard and physical renderers as well as the Arnold render. And we have a bunch of tutorials which are shorter, broken down into 5 to 7 minute segments that have actually been done by EJ Hassafras, a leading C4D trainer. And from there, you can also register for an account and sign up for a new account with credit. So all of that, again, is accessible directly from the C4D menu. And if you click on any of the top links here, for instance, pricing, that'll bring you to our pricing page. And as I scroll down here, you can see these are the different prices we offer for both the standard and physical renderer as well as Arnold render on a per machine per hour basis. And I'll go ahead and explain a little bit more in detail what the difference between preemptable and standard machines are and why the cost is different. So I'm going to go ahead now and actually just jump back into C4D. and walk you through the process of launching a render. So before you do that, as I mentioned, you have to have the plugin installed, and that's done by going to the Google Zync menu in Pipeline and clicking the Download Installer button. When you do that, you're going to get a client app, and this is the client application. And this, once you register for an account, allows you to name your own custom Zync user site. In this case, mine is named demo.zync.io. You log in through your Google account to make sure it's authentic and secure. You actually install and update the plugins from the plugins tab, and you can see in my case, I've updated and installed all of the latest plugins. And then we have some options for controlling the number of transfers happening at one time, as well as viewing those transfers, which will be active in a moment. And you can actually view the job log for everything that's happened in the past. You can do a little bit of troubleshooting here. But by and large, your client app interaction is going to be fairly lightweight. You're going to install this, you're going to update the plugins, and then you'll be good to go with launching renders. So the key focus in all of this is, as I mentioned before, system integration with C4D. So you as the artist are to go ahead and work inside of C4D just like you normally would. There's nothing special you have to set up in terms of repathing, rendering, takes, any of that. Everything that you do as an artist should not change one bit when using Zync for cloud rendering on Google. So I'm ready to go ahead and launch a render since there's nothing I need to do differently here as the user or as the artist. So what I want to do now is go back to that pipeline menu. Actually, first thing I want to do is make sure I save my project. So I'll save that. And once I've saved that, I'm going to go ahead and go to the pipeline menu, and then I'm actually going to execute and launch a render from Zync. So I go to pipeline, I go to Google Zync, and I go to render with Zync. So that's going to go ahead and launch the Zync dialog box. And you can see here, this is essentially the submission tool that we built inside of Cinema 4D. And from this, you're able to manage and control all of your settings. So everything that you see here is taken from what you've set up in your render settings inside of Cinema 4D. So you can choose different takes if you have those. You can modify and overwrite your output image path. But again, I recommend you as an artist to go ahead and work as you normally work, set everything up inside of Cinema 4D, and let Zync read from that. And it makes everything as seamless and easy to use as possible. So you can see here that I already have a specified output path that I've set inside of C4D, and this is where the render frames are going to go once they're complete. So I don't have to go, again, as I said before, FTP anything or download anything and move it to my output folder. Zync is automatically going to put those rendered frames right back where I told it to inside of Cinema 4D. We've got some options here around machines and frame range, but what I really want to first address is how we handle file I/O, because typically we get a lot of questions around, oh, do I have to have a really fast internet connection to do this cloud rendering? Not with Zync. With Zync, we've really designed the interface and the file management to be as seamless as possible. And as a side note, when we built Zync, we actually built it at a visual effects studio in Boston that was founded by a gentleman who spent many years working at Digital Domain and Industrial Light and Magic. And they really understood pipelines, but they didn't have a very fast connection at their first studio. They had a 50 megabit down, only 5 megabit up. So what we've done is design the ability to sync your assets to Zync ahead of time, so you're not pushing everything at render time. So what I have the option to do is here, click on upload only. And when I do this, it's going to gray out a lot of the other options, and it's just going to let me set up my cloud storage bucket. And I'll show you where that's managed in a moment. But I already have this project that I've run before. So I'm going to use my existing project, and I'm simply going to launch that. So once I do that, the job's been submitted to C4D, and no rendering is happening right now. The only thing that's happening is that Zync is going to check all the files that are needed for this render, and it's going to make sure they're uploaded to Zync. And if they've already been uploaded, there's nothing that's going to happen. There's no additional and unnecessary file I/O. So if I go to the client app, just to show you here, you can see in the log here, in a minute, Zync is going to actually go ahead and start showing you the status of this job. and what's happening, and I'll come back to this in a minute. You can see it's actually already started. It's reporting the scene file information back from the desktop to Zync, and it's going to look for any unuploaded files. But again, in my case, I've run this demo many times. All those files are up there. So no additional assets are going to be transferred. But the idea is if you bring in a new asset, you can go ahead and sync all that. And I'll go ahead and minimize this. You can go ahead and sync that by running the upload only job and run it every day, run it every morning. So this way, this ensures that all of your assets that are needed for rendering are actually synced to cloud and to our Zync storage even before the render. So at render time, Zync will make sure that everything is up there. If any new files have been uploaded or introduced into the scene rather, they will be uploaded before the render actually kicks off. So you don't have to worry about managing that, managing versions. Zync's going to handle all of that for you. And then it's going to go ahead and kick off the render. So when I clicked on this upload only button, what it's doing, it's looking at the active C4D project and all of those files, then textures that are associated with it. But let's say maybe you have some textures that you think you're going to want to bring into the scene later, but they're not in there yet. So what you can actually do is also choose as option to select auxiliary files. So when I do that, you can see I have a file browser, so I can add both an individual file or add a directory. And when I do that, you can see I have different textures I can link to. So the great thing about this, and I'll just cancel out of this, is the fact that what you can do is even upload assets that are not in the scene yet, but you think you might need. So again, with Zync, we're all about managing your file access and minimizing unnecessary file I/O and the bottleneck that happens typically with cloud rendering, pushing everything up at runtime. We allow you to sync all of your assets, and you can run this function as often as you want. And if there are no new assets to sync, then nothing gets uploaded. So it's a great way to handle all of your file transfer without having to do, as I said, any sort of manual FTPing of files up and down, but rather Zync is able to look at the C4D scene, look at all the associated reference files, dependencies, materials, assets, and textures, and upload those for you. So I'm going to unclick this, and now let's move to actually submitting a render. And we're going to go ahead and submit this render and look at the output in real time. So you've got options here for job priority and notify on job completion. So notify on job completion will actually send you an email when the job is done. Job priority is a legacy feature that we used to have when we didn't offer as many machines, but that way, if you're submitting a number of different jobs at once, you can prioritize which ones get done first. The higher the number, the higher the priority. So the default is 50, the lowest is 99, and the highest is job priority 1. But honestly, given the fact now that we give you up to 500 machines, you're really probably not going to need job priority. You'll always pretty much have enough machines to run at all times without having to prioritize that. So if you've got 3 or 4 jobs and literally you want to throw 100 machines at each one of those, if you want to literally throw 6,400 cores at each of those jobs, you can do that. You still don't need to worry about job priority. So what I'm going to do now is actually launch a render. And to do that, I go to the machine settings, and I can choose the number of machines and the machine type. So at the bottom here, you can see my frame range. I've got about 123 frames here of this sequence. So Zync, again, is looking at the entire project, and you can always overwrite this. But let's go ahead and actually render all 123 frames. So what I'm going to do in this case is I'm going to use, let's say I'll go ahead and use 20 machines. This might be even a little bit overkill for this job, but we want to get the job done really fast. And then I have different machine types. So as I pull this menu down here, you'll see I have an 8-core with 16 gigs of RAM, 16-core with 32 gigs of RAM, 32-core with 64 gigs of RAM, and 64-core with 128 gigs of RAM. And you can see these are all priced differently. Obviously, the more powerful machines are more expensive, but that doesn't necessarily mean that they're really more expensive in the end, because of the fact that both the C4D renderers, the standard and physical renderer, as well as the Arnold renderer are very well threaded. So as I mentioned before, you're paying per minute after a 10-minute minimum. So if you've got a job that's going to run a complex job, let's say you're going to run it on an 8-core machine and it takes you an hour. Well, if you run that on a 64-core machine, it's probably going to take you a quarter of that time. So the cost is going to be a quarter as much based on the full hour. So generally, with the machines that I show, they're more complex, so I tend to go with the more powerful machines. Now, we also have a second set of the same machines, and these are called preemptable. So what these are essentially a class of machines that are offered on Google Cloud Platform that are spare capacity machines. So as I mentioned, we literally have millions of machines, millions of cores on Google Cloud Platform, and they're not always used all the time. So let's say you want to take a chance and use some preemptable machines. You can do that, and you can see they're priced significantly lower. And the advantage is obviously they're less expensive. There is a bit of a risk that if those machines get called into someone else who's using Google Cloud Platform, you could have those taken away from you. If that is the case, Zync is set to auto retry, but currently you do lose any of the progress that you've made. So with preemptable machines, the published rate of preemption on Google Cloud Platform is between 5 and 15% in a 24-hour period. And again, that's for all Google Cloud Platform preemptable machines. So my general rule of thumb for people doing renders out of Cinema 4D is if you've got a frame that's going to take you, 10 hours a frame, it's better to go with the on-demand machines. Now, if you've got shorter frames that are only really going to take you a handful of minutes, maybe, or up to an hour, it's probably lower risk that those machines are going to get taken away by someone else's needs. So you can go with the preemptables, and they end up being much cheaper. In this case, for this particular render, these frames actually render really quickly. So what I'm going to do is use the preemptable machines here. And you can see I want to use the 64 core machines. And that's priced at $1.03 an hour versus $3.16 an hour. So it's a significant cost savings. So I'm going to go ahead, I'm going to use the preemptable machines here. As I said, I'm going to choose 20 of them. And you can see my estimated cost per hour is $20.60. But keep in mind, this is if you were to run all 20 machines for the full hour. Now, let's say the whole job gets done in half this time. Then you're only going to pay half that amount. So after that first 10 minutes, as I mentioned before, we only bill on a per minute basis. So it really is cost efficient and cost effective. And in particular with C4D, if you've got shorter renders, you're generally pretty safe to use preemptable machines and save a significant amount of money. So I'm going to launch this job in one moment, but I also want to point out the cost calculator. So this is a button I can click, and this is actually going to bring up a web page. And you can also link to this from our Zync pricing page. So when you see Zync pricing here, you can see at the bottom a link to our calculator. So what this calculator allows you to do is select the type of VMs you're running, the machine types that you're using in the application, and then actually after you've run some test frames, put in those numbers, and Zync will give you an approximate actual cost for the job. So in this case, let me go back here to this particular project, and I think this takes about 3 minutes a frame, I believe. So I'm going to go back to the cost calculator, and I'm going to use the preemptable machines, and I'm going to use the 64 core machines. I'm using C4D. I'm using the physical renderer here, and let's just say I rendered 5 frames in this test, and the total time, I said it's about 3 minutes a frame, so it took 15 minutes to do all 5 of those frames. And the total frames in the job, again, going back to C4D, you can see here it is 123 frames. So when I jump back, I just plug in 123 frames, and I can add to the estimate. And you can see now Zync is going to take that data, and it's going to essentially extrapolate out how long this render is going to cost you. So the estimated cost for this is going to be $6.33 to render this job. Now, keep in mind, with this particular job, which I'll launch in a moment, this actually, if I were to render this locally on my machine, I certainly don't have a 64 core machine, so it takes significantly longer. I think I was saying last time it's about 21 hours to render this whole thing locally. And I can do this in a matter of minutes. And we're just going to go ahead and do this now in real time on Zync. So I've got the frame range here. I've obviously chosen my number of machines and the types of machines. Frame step is how many sequential frames are going to be rendered, and the chunk size is how many frames in each task are going to be done. So I've got about 120 frames here. I'm going to go ahead and let's say I'll chunk this to 6. So I should get each task, each of these 20 machines, and I'll just go ahead and add a 21st machine. It's going to be doing 6 frames. So that's going to go ahead and distribute each of the tasks. Each of those 21 machines are each going to be working on 6 frames. So I'm going to get this whole thing done very quickly in parallel. And before I mention, why aren't I spinning up 123 machines to do this? It is important to note there's a little bit of startup time at the beginning of a job, a bit of machine overhead that takes time. And the fact that these renders are so short, I want to actually make sure I'm getting close to my 10-minute minimum per job. If I was in a super rush and didn't care about cost whatsoever, then sure, I'd spin up 123 machines. But in this case, I want to try to get 10 minutes out of each machine running. And I know each frame is about, I think, 1.5 to 2 minutes, 3 minutes maybe, depending on the frame here. So I'll go ahead and try to get 10 minutes out of each of these, and I'll go ahead and set the chunk size to 6. So the frame range again here is set for me. I can modify that if I need to. I've got my frame step. I've got my storage set up, and I've got my render, both physical, which is selected for me, and I can overwrite the resolution. So everything here is set up. I'll go ahead and launch the job, and the job has been submitted. So we're going to go ahead and hopefully get this done in the next few minutes. Let's keep an eye on the clock now. It's 9:26 a.m. Pacific time when I submitted the job. And hopefully we should have all these frames rendered and deposited back to my local output directory in the next 15 or 20 minutes or so. Again, there's a little bit of overhead for the machines to start up, and there's actual time it takes for those frames to download as they complete. But I've gone ahead and submitted the job here. And if I were a C4D artist, again, rather than lock up my machine for 21 hours waiting for this render to happen, it's free for me to use. So I can go ahead and open up another scene, maybe even start working on this or tweaking this to get different looks. But the idea is all of those assets, all of the rendering now is offloaded onto Google Cloud Platform. And in a few minutes, I'll have 21 machines, 64 core machines, mind you, up and running and cranking away at this. So I'm going to go ahead and close this. And now let's actually move over and take a look at the Web Render Manager. So this is the part of the process where you can actually view the status of all of your machines, see all of the processing happening, control everything. And to get to that, I can either type in my web URL or actually go back to my client application. And you can see here, it's Zync is checking to make sure all the source images and textures are there and reporting those back before actually starting the job. But I can go back to the Login tab, and I can click on Open Web Console, and it's going to go ahead and open up my web console. So you can see now that this job has just been started. This is, again, all happening in real time, and the instances themselves now are just spinning up. Again, it's important to note here, and I'll take you through the different options in the web console while we wait for this job to spin up. But all of the VM configuration is done for you. You don't have to worry about licensing anything from Maxon in terms of your Cinema 4D render nodes, or even in the case if you're using an Arnold render, all of that is taken care of. So we on the back end have arrangements with all the different software partners, whether it's Maxon or whether it's Solid Angle, to allow us to offer this software and these renderers at scale. So in a few minutes, this is going to go ahead and start up, and you can see all of the different information here that's been set up. So we have the machines, 0 of 21, and as the machines come online, we'll start to see all those machines spin up. The machine type I'm using, so I'm trying those Preemptable machines, the 64 core, 128 gig machines. You can see I'm using the physical renderer. You can see that output directory. So this is my output directory down here, and it's empty right now. But as those frames finish rendering, they're going to go ahead and actually get downloaded right back to my local output directory. So those are going to start up. We can see the chunk size. Again, each of those 21 machines are currently going to work on 6 frames at a time. The resolution, as well as the take, and the output format, which was set as EXR. So you can now see I've got all those tasks lined up here, and in a few minutes when things start running, I'll be able to see the job log, I'll be able to see the runtime of all of that. And runtime you're only charged for as the actual machines are spun up and rendering. So during this status of preparing the machines, you're not getting charged for anything. We can see our first machine is now starting up and doing a pre-flight. And once the job starts, we'll actually see those machines up and spinning. But a few more things I want to just point out very briefly before I take you through the rest of the web console is the options in the actual job menu. So with any one job, You've got an option to restart the job, you can cancel the job, you can view the job log, which probably isn't very exciting right now, but we'll go ahead and load it up anyway. So you'll actually be able to see the status of everything happening here. So this is what's happening on Zync. And the nice thing to note about this is everything that you see in the job log is repathed to match your local environment. So as a user, even though all of this is now running on the cloud, everything is repathed locally. So it's just as if I'm running a local render farm in terms of the log information I'm seeing, in terms of the activity of everything. But you can see now it's configuring the nodes, setting up the licensing, and preparing the data. So I'm going to go ahead and close that and point out a few more things you can do here. You can view the job stats. By changing the job options, this is going to allow you to actually put more machines in here. So let's say you're working with a longer render, or you've submitted a job and you're realizing it's going to take more time, well, then you can simply go ahead and add more machines to that, or even change the priority. But again, priority, not as important when you've got up to 500 machines now that we give you with Zync. So that's the job controls you have, and we're actually going to go ahead now and jump out to some of the other options within the Web Render Manager, because I think it's important to note and show you all of the back-end features and functionality that we've built. So when I go to the My Account tab, we're able to see a bunch of different options. So the Config tab is where you can set up custom shaders. So quite popular are the AL shaders for Arnold. So you would edit that and actually just put in your local path to where those shaders reside if you're using those, and Zync is going to go ahead and upload those before the render. And it's also important to note for Nuke, we do support custom gizmos. So if you're doing your C4D render compositing inside of Nuke and you've got custom scripts inside of Nuke, you can simply point to that directory in your local machine to make sure all that is uploaded as well. The next tab is the usage, and this is really probably the most popular feature with all of the producers out there who use Zync. So here is where you get a full breakdown of all of your usage on a per project and per user basis. So being that Zync is a Google Cloud Platform product, at the end of every month, you do get a bill, a line item bill for each of the different machine types you used for Zync. So let's say you used 100 hours of the 16 core machines and 50 hours of the 64 core machines. You get a bill for that at the end of the month. But what we give you in the Zync console itself is more of a real-time breakdown, as I was saying, on a per project and per user basis. So you can specify a date range going back as far as 90 days. And you can see all the different software that was used. So here the breakdown is by machines and software. You can see how long the render time is, what the approximate cost of that is, and the number of jobs run. So you're also able to do that on a machine basis, based on the types of machines, straight up, not including the software. You can actually see a breakdown of the software. So in this case, I've run a few jobs, and this is in the last month, in fact. So I've run a few jobs on C4D as well as V-Ray and what the cost has been there, and then by different projects. So as I'll show you in a moment, you have a whole bunch of different project storage options. And of course, if you're submitting different jobs, each one is a different project. So you can see how much render time I've done and how much I've spent on each of these different jobs. So in the case of this construct September scene, which I just submitted, I've run 6 hours previously, or almost 6 hours, and I spent $28.27 in the past. And all of this, you can now see the more detailed job breakdown here on an individual job basis. So not just the construct scene or the construct September scene, but how many times each time I've run that, all the different job IDs, how long it's taken, and what it's cost. And then at the very end, you can see the breakdown by users. So I share this account with other people at Google for testing and demos, and you can see who's rendered what and how much they've spent and how many jobs they've run, as well as your rendering cost per day and the approximate cost of storage. So I'll talk about storage in a moment, but it is important to note that storage is charged separately from the per hour rendering fees, and that's 20 cents a gig a month. But generally, storage is no more than maybe 5 or 10% of your bill every month. So again, the usage tab gives you significant breakdown of all of your different jobs on a per project, user, software, machine basis. So you can download a CSV from this, and if you need to bill back the projects to customers and clients, you can actually specify that yes, that we use this many machines or we spent this much money rendering this particular project for a job. I'm going to go ahead and go over to the users tab, and this is where you add different users to your account. So if you're a studio, you can add multiple users simply by putting in their email. You can give them admin privileges or not. The difference between admin privileges and non-admin privileges are that all of these tabs are only available to admin. If you're just a regular user, you can't add new users, view the usage, or edit the configuration files. And then we have a projects tab. So as I was showing you before, when we go ahead and upload a data set for a particular project, that's all stored on Google Cloud Platform. So you can see the disk usage for each of these, and you can delete these projects at any time. So in this case, we're working with the Construct September 2017. You can see it's 1.2 gigs, and that is a combination, again, of the assets that have been uploaded and textures that are needed for the actual project, as well as the render. So every time I'm doing a render, Zync's going to keep a copy of that, and you can always delete that project at the end of a job. In this case, this is a demo site, so I tend to leave this up. And again, at 20 cents a gig a month, it's relatively inexpensive, and it's also a good data backup if you need to re-download those frames. And I'll show you how to do that in a moment. And then I'm going to go over to the browse files. So within the file browser, I can actually go ahead and look at all of the different projects that are stored on Google Cloud Platform. And it's important to note, everything I'm browsing here is actually on Google Cloud Platform. But the nice thing to note is it's all repathed to match my local environment. So you can see I've got my project and all of my renders that have come out of this before, all the EXRs that I've rendered in the past. So everything that's uploaded to a particular project that I was showing you in the usage tab is actually viewable and browsable from the browse files tab. And then I'll go ahead and move over to support. Just a quick note that we have documentation that's available at docs.zyncrender.com. So when I go over to that page, you can see all of our FAQs and configuration, which you can look at longer if you'd like yourself. And you can always email zyncsupport@google.com, and support's available Monday through Friday, 24 hours. So I'm gonna go back to my main page, and let's actually check on the status of this job. And you can see now we have a significant amount of things are actually up and rendering. So we've got 19 of those 21 machines are now spun up, and as I scroll down here, you can see all of those different VMs on Google Cloud Platform up and rendering. We can see the overall status, and we can see the individual per frame status as well. So those first 5 frames, which were on that first machine that spun up, were already done. And those 5 frames have already been downloaded to my output directory. So when I go and open up my output directory, before I showed you that was empty, and now you can see it's starting to get filled with those EXRs, and they just completed about 2 minutes ago. So we'll look at the first EXR, nothing too fancy here, but we'll go ahead and play all of these back when they're done. But that job has gone ahead and finished. And as I said, this is a very quick render, and we have very powerful 64-core machines. So the job was done in only about 3 minutes to render 6 frames. So very, very quick, probably quicker than a lot of what you have. But again, we're able to rip through these renders really, really quickly. And you can see those other frames in the next task are actually just finished rendering, and they're downloading. So the very cool thing is here in real time, all of these frames, as they finish, the progress goes from rendering to downloading to done. And you can see those frames depositing right back into your local output directory as if it was a local render farm. I keep saying no need to have to go FTP or manage those files, but it really is a huge convenience that when Zync is done rendering, it literally just puts those frames exactly where you told it to. So we've got a bunch more frames that are finishing up here, and we'll have this whole sequence done pretty quick because we now have most of these machines up and running here and rendering. So I just want to go ahead and minimize this and point out a few last features, and then we'll go ahead and wrap up. So I was mentioning the job logs before when I was showing you that. You can also click on the log for any individual task, and again, you'll see everything that's repathed to a local environment and all of that detail for you. And wow, this job is actually running really fast. It's pretty much almost done. Anyway, that job log is going to give it a few more minutes to, actually, I'll go ahead and skip this. You can download those job logs once they populate, but this job is running so fast, we're pretty much already done here, so I'll skip out of that. But the cool thing to do is you can go ahead and, again, see the overall progress here. But if I need to re-download any one of these sequences of frames, I can simply click on the selected task, go to the option to either requeue, skip, or re-download, which is most users need to do that. If they, let's say their files locally got deleted, they can go to any one of their jobs, either an active job, or they can show all the completed jobs. You can see there are a bunch of jobs that have been done in the past here. I can go to any one of those jobs. I can go ahead and pull up the selected frames, and I've got the same option to re-download those. So access to all of your previously rendered frames that are on the Zync storage, as long as you don't delete that storage. So we'll go back and check out this this real-time live job here, and you can see the 88% done. Again, we can skip to the next set of tasks. Most of these are taking about 30 seconds a frame, so super fast here. Again, 64 core machines, very powerful. We can see the status here. Everything is done. So all of those machines now are going to be released, and you're only charged for the consumption. Of course, there's a 10-minute minimum, and since these renders were so fast, this is going to get rounded up to 10 minutes. But you get the idea here. For the purpose of the webinar, I really wanted to rip through these frames. This whole job is done. If I show the stats here, we'll show the completed job, show the stats, 14 minutes and 37 seconds. So that was the runtime start to finish. And again, I'm talking about 21 hours on my machine to render that locally. So I just look at the cost savings that cloud provides you with Zync on Google Cloud Platform. It's not even necessarily, don't think of just the cost you spent to render this job in 14 minutes. Think of the hours and hours and hours you got back to do other work. So I've got my output directory here. I've got all of those frames. We'll go ahead and select them all and load them into RV. And then I'll go ahead and play those back for you. So as I launch RV here, we can see the actual final finished render that was done in a matter of minutes, as opposed to having to go ahead and wait all that time to render locally. So I'll go ahead and load those in. And I'll just go ahead and scrub through this here, since there might be some lag in the playback. But you can see we've got our nice finished rendered sequence here. Some nice motion blur rendered out of C4D, and all done on Zync in a matter of minutes, as opposed to a matter of hours. So I'm going to go ahead and end things there, and I'll turn it back over to Mark at Maxon to address any QA questions you have. Again, I just want to reiterate, thank you for your time. And if you go to the pipeline menu inside of R19, you can access all of the Zync information, or just open up a web browser and go to www.zyncrender.com. And from there, you're able to register for an account. You can view tutorials, see pricing, read documentation, and whatever else you might need. So I'm going to go ahead and turn it back to Mark. And thank you, everyone, for your time.
Awesome. Thank you very much, Todd, for the presentation of Google Zync for Cinema 4D. We got some questions from the audience during the webinar, so I'll just start with the first one that came up from Stephen. Stephen was asking, if you use preemptable machines and they are pulled away during your render, do you actually lose the completed frames that were started on the preemptable machines?
Very good question. And the answer to that currently is yes, you do lose those frames. We are looking at a way in the future to potentially preserve a partially completed render. But as of today, if you use a preemptable machine and it is taken away, you do lose the partial completion of that frame.
Okay. Next question, also for the preemptive mode, came from Fernando. Fernando is asking, in preemptive mode, if my render is canceled and then picked up again, am I charged for the time used for the canceled instances, or just the instance that was able to complete the job?
Yeah, good question. So you're asking about preemptables, and if they're canceled, are you charged? So you are charged. So if a machine is preempted in the middle of a job, that amount is still charged to you as compute and render time. Again, it's one of the reasons why it's so significantly less expensive, is because of the fact that there is a risk of being taken away. But again, just to reiterate, we found that based on the published Google preemption rates that we published of between 5 and 15% within a 24-hour period, and you'll never have a single machine for more than 24 hours in preemption mode. Based on that 5 to 15% preemption rate, generally, if you've got frames that are taking you, 30 minutes or an hour a frame, even you're pretty safe with those. You want to make sure you go ahead and set your chunk size to 1, so each frame is being done one at a time. But currently, yes, those are charged even if a machine is preempted.
Okay, thank you for the answer. The next two questions are about the render engines. As we learned, currently you're supporting Arnold, the advanced renderer, and the physical renderer. And Vlad and John, they were asking if there is support for Corona or any other GPU render engines. So, do you plan on supporting them?
Yeah, great question. So do we plan on supporting GPU renderers? Yes, it's something we're definitely looking at adding support for in the future. At the SIGGRAPH show this year, a few months ago, we did a technology preview of V-Ray GPU rendering for another 3D application. So once that releases, it's our plan to add GPU rendering support for host applications such as C4D as well.
So thank you. Next question came from Andrew. Andrew wanted to know what's it about plugins? Can you use plugins in your C4D project and render it via Zync?
Right, so good question. So currently, we don't have support for any additional plugins beside the renders that we've described, but we are working with several of the different vendors out there. Certainly the popular ones such as Turbulence FD and XParticles, and it's our hope to enable support for those in the future.
So I think that also answers the question from Michael regarding XParticles. Another question regarding GPU-based engines like Octane. As you already said, Todd, you're planning to turn up support for GPU rendering. Another question from Raphael. If my machine is turned off while Zync renders, Zync saves the files locally until I turn mine on?
Yes, good question. So if your machine locally is turned off while everything is getting rendered, yes, you don't lose any progress in this case. Of course, all of the rendering is happening on cloud, and all of those frames are stored on Zync storage as a backup. And as I showed in this session, you can re-download any individual frames by selecting a task. So if my screen here is still sharing, I can show you, but if not, basically you just have to have the client application open. So if the client application is disconnected for any reason, the rendering of course continues, but the downloading of those frames is interrupted. So once you reconnect the client application or log back in with that, then the rendering resumes. Sorry, not the rendering, the downloading resumes, but the rendering itself is not impacted at all, whether or not your local machine is online.
Great, thank you very much. Another question from Stephen was, how are the 6 frames distributed over the 21 virtual machines in your demo today?
Yep, good question. So how are the frames distributed over the virtual machines? So in this case, each of the 21 machines is working on 6 frames at a time. If I go to the, Mark, is my screen still sharing, or is it back to another screen? If you can you see my screen now still?
Yeah.
Okay, great. So you have this chunk size, and this essentially determines how many frames are going to be rendered on one particular machine. So if I went ahead and, as I did before, I set up 21 machines and I set the chunk size to 6. That's basically because I know I have about 123 frames here to render. So if I multiply out 6 times 21, that's it's basically going to cover the frame sequence there across those machines. But the short answer is the chunk size is how many frames in a row are being done on any one individual machine.
I see. Next question comes from Rick. Is the 10-minute minimum per job or per monthly total?
That is per job, per machine, the 10-minute minimum.
Okay. Next question from Brett. When rendering with V-Ray or Arnold, we sometimes use external proxies or irradiance maps. These seems to be absolute path-based. How might Zync handle these?
Right, so from what I understand, IR caches are supported. I think you might need to actually select them as an upload in the auxiliary files, but those should be detected or allow you to upload them and support it during renders.
Okay, thank you. Another question from Andrew. What is the maximum multiple downloads / transfers in the settings?
Oh, great question. What are the multiple downloads, transfers, in the settings? So You can set that as high as you want. It really depends on your bandwidth. It's on Google's network, so our capacity for pushing things is quite high. But if I go to my client app, in the configuration, I can choose a number of max transfers. It's set to 10 as default. But if I've got a 1 gig connection, I can up that to 100. And what we also have, which I didn't have time to point out, in the Web Render Manager, is the transfers tab. So there's nothing live here, but if you have a bunch of different jobs going on at once, you can actually prioritize which frames or which number of frames come down at first. So let's say I've got, in this particular job, I had 81 frames to come down. And let's say I had limited bandwidth, I could specify which tasks I want to prioritize. So you have a great deal of control over the number of tasks and frames coming down in a transfer.
Thank you. Another question that came up from multiple attendees was if the whole webinar will be available for viewing afterwards. And yes, we will publish the webinar shortly afterwards on our YouTube channel, and we will send you all a mail with the link to our YouTube channel so you can watch the webinar again afterwards, just in case you missed some important points. Another question that came from Marian. In this case, each machine rendered only about 2 minutes. Wasn't the minimum 10 minutes per machine? I think it's referring on the chat.
Yeah, great question. Yeah, so the minimum is 10 minutes in terms of how you're billed. So that would actually be rounded up. Even if it's 3 minutes to render those frames, you're still going to be charged for the minimum of 10 minutes. But again, I would imagine most of you doing work out there are probably doing even more complex scenes than this and rendering several minutes of frame. So in more of a practical real world scenario, it doesn't happen to come up as much. And if I really wanted to make sure I got my money's worth, when I go to actually launch the job, in this case, we can say, let's say it takes a minute a frame, right? So I will go ahead and I would set this back down to, let's say 10 machines, and I would chunk size to 10. So each of those 10 machines are going to work on 10 frames at a time, and that's going to get me closer to that 10-minute minimum in terms of cost efficiency.
Great, thank you very much. So for the moment, that was the last question that came here via the chat. So yeah, basically, thanks again, Todd, for holding the webinar. As I already pointed out, we will publish the webinar on our YouTube channel shortly afterwards. And I think, Todd, it's safe to say that if there are any additional questions, people can just go to Google Zync and contact you to ask their questions, right?
Yep, absolutely. You can email info@zyncrender.com, or if you go to the Google Zync menu in R19, you go to more information, and then from there, you're able to contact us here at the bottom right, which will give you the same info@zyncrender.com email.
Great. We had just one more follow-up questions. I think the whole distribution on the machines, that is quite a tricky topic. Follow-up on the question was that from Stephen, 6 frames, the chunk is assigned to a single machine. So one or the 21 machines, is that correct? So all 123 frames are loaded and rendering simultaneously?
Yes, that is correct. In terms of distribution, the chunk size is done globally across all the machines. So very good question. When I go ahead, and I'll bring up just the render menu one more time here. So yes, in this case, in this particular setting, I have 10 machines and the chunk size is 10. That means each of those 10 machines are going to work on 10 frames at a time. So it's a global distribution in terms of how the rendering is working.
Okay. Thank you very much for answering that one. Yeah, I think we are almost online for an hour now. No more questions here in the chat. So Todd, I would say thank you very much for presenting Google Zync to our attendees. And just in case there are some more open questions, please just refer to the Google Zync webpage. I think that's it from my side. Thank you again very much, Todd. And we will inform you as soon as the recording of the webinar is online on our YouTube channel. Thank you very much for attending to everyone, and have a nice day. Thank you.
Thank you. Bye-bye.